This is the third part of the chapter number 6, and in this part we will solve the exercise which are based on the laws of indices. So we will understand first what are these indices. This indices is actually the plural of index. What is this index? For example, I am writing 3 to the power 2, 6 to the power 5. You can see this power is called the index, and here this 5 is called the index. And similarly, if I will write 3 to the power 1 by 2, here there is fractional index. In laws of indices, we have x power m into x to the power n is equal to x power m plus n. That means when the bases are same, this x is base, this x is base, they are same, then powers are added. That is, for example, 2 to the power 3 into 2 to the power 5. So what will happen to the powers? Bases are same. In multiplication, we can see 2 to the power of 3 plus 5, that's 2 to the power of 8. And similarly, if we have 100 to the power of 2 into 100 to the power of minus 1, then we can write 100 to the power of 2 plus minus 1. That's 100 to the power of 2 plus into minus is minus 1. That's 100 to the power 1, which is equal to 100. Now next we have x to the power m divide x to the power n. So in division we should do the subtraction of powers, x to the power m minus n. That is, example, 2 to the power of 3 divide 2 to the power of 2 is equal to 2 to the power 3 minus 2. That's 2 to the power 3 minus 2 is 1. That's 2. So you can see here in multiplication we are adding the powers, and in division we are subtracting the powers. You should understand. And sometimes this will be like this: x to the power divide m divided by x to the power n, and also we can write it x to power m minus n. And next we have, if x power m whole to the power n is there, then what we should do, x to the power m into n. For example, 3 to the power 5 whole power 2. What does it mean? It means 3 to the power 5 into 2. That is 3 to the power 10. This is the answer of the question here. Now next, if we have square root of x, this square root means x to the power 1 by 2. And you know these are also called the surds. When we have the root, the fractional power, these are called the surds also. If I have nth root of x, so I can write x to the power 1 by n. What does that mean? For example, if I have square root of 3, it is 3 to the power 1 by 2. Or if I have 2 to the power 1 by 2, I can write square root of 2. If I have cube root of 13, so it is 13 to the power 1 by 2, 1 by 3. If I have sixth root of 20, so it is 20 to the power of 1 by 6. This is actually the fractional power. When we have these fractional powers, we can say them, these are called the surds, and the surds are always the irrational numbers. And these things you will learn in the coming chapters. And one more, if we have x power m is equal to x power n, you can see here x is there, same number are there, only the powers are different. So this implies m is equal to n. What does that mean? If we have 2 to the power x is equal to 2 to the power minus 1, bases are same, it implies x is equal to minus 1. These results you should remember, because we are going to use these formulas, use these laws of indices in the whole exercise. We have back to back two exercise, and also we have in the next chapter, that's algebra 6 algebra 6, in the last exercise we will be using such formulas. Now next we have x to the power minus n. If we want to make it the positive, I have to write 1 divided by x raised power 1, x raised power n, that is the reciprocal of this. And if it's x by y whole power minus n, so to make the power positive, I will write the reciprocal of this, that's y by x whole to the power n. I will give here the example. If I have 2 power minus 3, it's 1 by 2 power 3. And sometimes if I have 1 divided by x power minus 1 minus n, so to make it positive I have to write its reciprocal, that's x power n. Giving its example, 1 divided by 2 power minus 3 is 2 raised power 3. So what we are doing when we have the negative indices, so what we are doing, we are taking the reciprocals. Once we take the reciprocals, our powers will become positive. You should understand this thing. Now here once again, if I have 2 by 3 whole power minus 1, this is the negative power, so how to make it positive? It's 3 by 2 whole power 1. Taking the reciprocal of the number, we are making it the positive. Remember these things. And we have one more, if x power n whole power m. What to do? It is actually x power n into m. So that's x power nm. For example, if I have 2 to the power 3 whole to the power 2. So what to do? 2 to the power 3 into 2. It is 3 into 2. That is 2 to the power 6. So you should understand, when there is the bracket, then powers are multiplied. Like m n into m. One more result you should understand, anything to the power 0 is always equal to 1. That's x power 0 is always equal to 1. If I have 10 power 0 is equal to 1. If I have 100 to the power 0 is equal to 1. If I have 99 to the power 0, it's always equal to 1. Anything raised to the power is always equal to 1. Or sometimes we have 1, we can write 1 as the power of, as power should be 0, we can write any number 1. Like this is the 1, this is the 1, this is the 1. Any number having power 0 is always equal to 1. Now you can see the exercise 3, page number 13. Page number 13 in your textbook. Work out, the first one is 25 to the power 1 by 2. Now you can see here it is 2. I will try to cancel this 2. If I will write, instead of 25, I will write 5 to the power 2. That's also 5 into 5 is 25. Then I will write whole power 1 by 2. We know here is the multiplication between this power and this power. So 5 to the power 2 into 1 by 2. 2 ones are 2 ones are. So it's 5 power 1. The answer is 5. Coming to the second one, it is 27 to the power 1 by 3. You can see this 27. Instead of 27, I can write here 3 cube whole to the power 1 by 3. Then 3 to the power, this 3 and 1 by 3, they are in multiplication. 3 into 1 by 3. 3 cancel, it's 3 power 1, which is equal to 3. Now here try to understand how I know that 27 is 3 cube. If I will write here 27, you can see here 27. Same, I will try to find its prime factorization. Likewise, we are doing the LCM. How to find the LCM? You might have gone through that. First, I will start with the 2. It's not possible since it is odd number. Then I will start with 3. I will check. Yes, it's possible. 3 9s are 27. Once again, I will start with the 2. It's not possible. Now 3 3s are 9. Then 3 1s are. You can see 3 into 3 into 3. That is 3 into 3 into 3. That is 3 cube. 3 times 3, here it's 1 1 1. So 3 times 3 is 27. That's why instead of 27. I wrote here 3 power 3. So I got the answer. Cube root of 27 is 3. Now next you can see here third one. It is 16 to the power 1 by 4. You can see, can we write any number to the power 4 which is equal to 16? Yes, we will check it here. Start with the 2 to find its prime factorization. 2 8s are 16, 2 4s are 8, 2 2s are 4, then 2 1s are 2. You can see 16 can be written as 2 to the power 4. So I will write 2 to the power 4. Then directly I will write 1 by 4 because I know this 1 by 4 should be multiplied to this. That's 4 4 cancel. It's actually 2 power 1. That is 2 only. Now you can see here this 25, I can also write 25 to the power 1 by 2 is actually the square root of 25. That we know that's 5. And here 27 power 1 by 3, it's cube root of 27. I know it's 3. And same here 16 power 1 by 4, it's fourth root of 16. That is 2. Now coming to the next one, it is fourth one. Fourth one is 1 by 4 whole power 1 by 2. When there is numerator and the denominator, you can see here, when we have the numerator and the denominator and we have the power, it means this power is for 1 as well as for 4. So I will write separately 1 power 1 by 2, 4 to the power 1 by 2. 1 power anything, it's always equal to 1. 4 to the power 1 by 2, that is square root of 4. That's 2. I can write directly. Or if you want, instead of 4, I will write this 2 square into 1 by 2. 2 2 cancel, it's 1 by 2. This is the answer of this part. Now coming to next, it's fifth one. Fifth one, you can see it's 9 to the power 3 by 2. You can see 9, I can write 3 square. Then into 3 by 2. 2 2 cancel. It's 3 to the power 3. That's 3 into 3 into 3, which is equal to 27. Now you can see the seventh one. What is seventh one? It is 16 by 25 whole to the power 1 by 2. Now you can see here, this 16 I can write 4 square. This 25 I can write 5 square whole to the power 1 by 2. Then I can write this 4 by 5 whole square whole to the power 1 by 2. Then I can write 4 by 5 whole to the power 2 into 1 by 2. That is 1. That's 4 by 5 is the answer of this question. Also we can write like this: square root of 16 by 25. That is square root of 16, square root of 25. That is 4 by 5. This is also the way to write the answer of the question. Now question number 10 from the same exercise. You can see it is 4 to the power 1 5 by 2 into 64 to the power 1 by 3. Now you can see here, there it is 3 and here it's 2. First I will try to eliminate this 2 and 3. Here 4 I can write 2 to the power 2 into 5 by 2 into 64. I can write 4 cube into 1 by 3. Then you can see here 2 2 is cancelled and 3 3 cancel. It's 2 to the power 5 into 4 to the power 1. Now you can see here I can write 2 to the power 5 into 2 to the power of 2, that is 4. So what is that? 2 to the power of 5 plus 2, that is 2 to the power of 7. That's I will multiply 2 7 times. 2 into 2 into 2 into 2, 5 into 6 into 7. 2 twos are 4, twos are 8, twos are 16, twos are 32, twos are 64, twos are, it's 128. 128 is the answer. I have written here the step-by-step answer, although you can find here only. Now coming to this 64, how I wrote this 64, 4 cube, you can see here it's 1 by 3. So I need to eliminate this 3, the cube root of 64. I will write here the 64, then I will start with the 2. 2 threes are 2 twos are, then 2 ones are 2 six are, then 2 eights are, then 2 fours are, then 2 twos are, then 2 ones are. You can see it's 2 twos are 4, 2 twos are 4, 2 twos are 4. So 4 into 4 into 4. That's 4 cube is equal to 64. Understand this thing, how we are writing. Why I took 4 only? Because I know that I have to eliminate this 3. How to eliminate this 3? I should get here the number instead of 64, the number carrying the power 3. That's only the 4. If it would have here like 6, then it was very easy to write 2 power 6. For example, if it would have 64 to the power 1 by 6, then what was the answer? Then I should definitely take 2 power 6 instead of 64 into 1 by 6. So it depends upon this value. This value here, it is 3, that's why I took here the 3. That's why I took here the 4 power 3. There you should understand this thing. This is the, now the question number 13, it is cube root of 20 equals to 20 power x. So the question is written, solve for x. We need to find the value of x. You can see we can write this 20 to the power 1 by 3. Since this is the cube root, we can write it as fraction. That's 1 by 3 is equal to 20 power x. Now you can see the bases are here the same. If we have x power a is equal to x power b, it implies when bases are same and there is the equality sign, it implies the powers will be equal. So here you can see the powers are, bases are same, so I can write it implies 1 by 3 is equal to x. This is the value of x. Which result we used? We used this result. Now coming to the 14th one, it is same question. It's 3 to the power x is equal to square root of 3 whole power 5. Now you know it's 3 power x only. Here square root means 3 to the power 1 by 2. I am just converting this square root to the power 1 by 2 whole power 5. Now you can see it's 3 power x equals to 3 power 1 by 2 into 5. That is 5 by 2. Now I can write here, since bases are same, so powers will be equal. So x equals to 5 by 2. Which result I am using? I am result x power a is equal to x power b. It implies a equals to b. Now the next exercise 3 star. You can see exercise 3 star on the page number 14. It's page 14. Here we will solve the question number 6. Question number 6. What is that? It's minus 125 whole to the power 2 by 3. Whole to the power 2 by 3. So you can see it's minus 125. Here I will try to remove the fractional part, that's 3. So what I should write? This 125, I will try to find its factorization. That's called the prime factorization. If I will start with the 3, you can 2, it's not possible, it's not divisible. 3, it's not possible. 4, it's not possible. So I will start with the 5. 5 2s are 10, 5 5s are 25. That's once again with the 5. 5 5s are 25, 5 1s are. So you can see we can write 5 cube equals to 125. Now you can see here it's minus 125. I will check. If I will write minus 5 whole power 3, yes, it's minus 125. because here we have odd number. If the power is odd number, then the answer will be in the minus. If the power is even number, then the answer will be in plus. So I can write here minus 5 to the power 3 whole power, or directly I will write into 2 by 3, because I know there is the multiplication between these two. 3 cancel, it's minus power 2, that's minus 5 whole square. So it's minus 5 whole square. That is 5 5s are 25, that's positive. That's plus 25. So this was about the question number 6. Now next you can see here question number 9 is there. Ninth one is there, it's minus 3, it's mixed fraction. Minus 3, 3 divided by 8 whole to the power 4 by 3. It's here, minus is here, 8 3s are 24, 24 3, it's 27 divided by 8 whole to the power 4 by 3. You can see I have changed the mixed fraction to the improper fraction by multiplying with 8 with 3 plus 3. Now you can see I can write here minus 3 divided by 2 cube, then whole to the power 4 by 3, because minus 3 divided by 2 into minus 3 divided by 2 into minus 3 divided by 2, that's minus 27 divided by 8. This 3 and 3 will cancel out, so it's minus 3 by 2 whole to the power 4. That is what? That is minus 3 into minus 3 into minus 3 into minus 3 whole divided by 2 into 2 into 2 into 2. 3 3s are 9 9 and 81 divided by 2 to 4 4 16 is the answer. This was ninth one. Now 13th one, you can see it is 7 to the power x equals to 4th root of 7 to the power 3. So it's 7 to the power x equals to, I can write 7 to the power 1 by 4, 4th root, that's 1 by 4 whole power 3. So I can write here 7 power x is equal to 7 to the power 3 into 1 by 4, that's 3 by 4. Here I can write x is equal to, when bases are same, because we have to find here the value of x, x is equal to 3 by 4. It is the answer. Now 14th one is here. It is similar question. It's 5th root of 5 is equal to 25 to the power x. How to do? You can see it's 5 whole power 1 by 5. This 5th root is 1 by 5 is equal to this 25. I can write 5 square whole power x, that's 5 power 1 by 5 is equal to 5 to the power 2 into x, it's 2x. Now bases are same, it means powers are equal. That's 1 by 5 is equal to 2x. Then doing transposition, you can see there 2, it's 1 by 10 equals to x. So x is equal to 1 by 10 is the answer of the question. Now moving towards the exercise 4, page number 15, you can see the first question workout. It's 3 to the power minus 2. So first I will try to make the power positive. So I will write its reciprocal. That's 1 divided by 3 power 2. It's 1 divided by 3. 3s are, it's 9. And the second one is 2 to the power minus 3. So what here, it's negative power. So what I will write first, I will try to make it the power positive. That's 1 divided by 3. That's 1 divided by 2. 2s are 4. 2s are 8. 1 by 8 is the answer. Now you can see the fourth one. What is fourth one? It's 3 to the power minus 2 whole power minus 1. You can see this minus 2 and minus 1, they are the powers. So we should multiply, because bracket is there. We should multiply there. It is 3 to the power minus 2 into minus 1. So that is 2, because minus 2 into minus 1. Minus minus plus 2 ones are 2 is there. So 3 square is 3 3s are, it's 9 here. So You should understand all the things what we are doing here. It's negative power here. So what I am doing here, I am trying to make it positive. There is a rule, there is a perfect method to make it. I am taking its reciprocal, and same here, and same what I am doing here. Here I have the power. This is like this, x to the power m whole power n. So I have used this, it's x power m into n, that's mn. This formula I have used. I can say this law of indices I have used here. Now coming to the next one, that's fifth one. Fifth one, you can see it is 3 power minus 2 divided by 3 to the power minus 1. You can see in division the bases are same, powers are subtracted, that's minus 2, then minus 1, that is 3 to the power minus 2, minus plus 1, it's 3 to the power minus 1. To make it positive, it's 1 divided by 3. Now see the sixth one, it's very easy, it's 5 to the power 0, it is always equal to 1. Anything to the power 0 is always equal to 1. You can see seventh one, it's 1 by 2 whole power minus 1. Here what we will do, we will try to remove this negative power. To remove, we have to write its reciprocal, that's 2 by 1 to the power 1. So by doing the reciprocal of this negative power will become positive, that's only the 2. Now next it is eighth one, it is 3 by 4 whole power minus 1. To remove this, I will take the reciprocal, that's 4 by 3. By doing this negative power will become positive, that's 4 by 3 is only the answer. Now next I will do here 11th one. 11th one is here, that's 5 by 3 whole to the power minus 2. First I will make the power positive, that's I will take its reciprocal, that's 3 by 5 whole square, that's 3 3s are, I can say 3 by 5 into 3 by 5, 3 3s are 9, 5 5s are 25. This is the 11th one. Now next it is 19th one. You can see the 19th one, what is it? It's 4 to the power minus 3 into 4 to the power minus 1 divide by 4 to the power minus 4. You can see here I will write 4 to the power minus 3. Since bases are same, powers I will add my plus minus 1 divided by 4 to the power minus 4. It's 4 to the power minus 4 divided by 4 to the power minus 4. This cancel, answer is only the 1 here. Now you can see what I did here. You should understand which results I'm using. You can see here I'm using x power m into x power n is equal to x power m plus n. This thing I have used here. That's why I wrote here 4 to the power minus 3 plus minus 1. This thing you should understand here. And here what I used here, it's simply x power minus n is equal to 1 divided by x power n. This formula or this law of indices I used here. And here what I used here x divided by y whole to the power minus n equal to y divided by x whole to the power n. Now the next 21, solve for x 21. It's 1 divided by 7 equal to 7 power x. We have to find the value of x. So I will write 1 divided by 7, 7 power minus 1 is equal to 7 power x. You can see 1 by 7, it is actually 1 by 7 power 1. If I want to write this number in the numerator, only numerator, then I should write 7 to the power minus 1, because I know 7 to the power minus 1 is 1 divided by 7. So here I wrote this. Why I wrote this you should understand, because I need to find the value of x. Here the base is 7 and I want make here the base 7. That is only possible if I will write 7 power minus 1. I should make the 7, I should write the 7 in numerator. Bases are same and there is equality sign. I can write, it implies minus 1 is equal to x. The value of x is minus 1. What we used here, we used x power m is equal to x power n. In this you can see here bases are same, so powers should be equal. M is equal to n. This result I have used here. Now next you can see it is 22. It's 1 by 4 whole power x equal to 4. So what I will do here, you can see here it's power x. It's 1 divided by 4 whole power x. So I will write here its reciprocal. We know its power is 1. So I will write 1 by 4, but its power will become minus 1. There is a need to make it 1 by 4 because here the base is 1 by 4. And here I would like to make the base 1 by 4 because the bases will be the same, so that I can write x equal to minus 1. This implies x equal to minus 1. This is the need of the question. Now next it's 23. That's very easy, you can do it. 24 I will show here. It is 2 by 3 whole power x equals to 9 by 4. Now see here, it's 2 by 3 whole power x. Shall I write this 9 by 4? First I will write it 3 by 2 whole square. So that 3 3s are 9, 2 2s are 4. It is the same number. Now I want here, the base is 2 by 3. Same number I want here. So 2 by 3 whole power x is equal to, I will write here 2 by 3. That is the reciprocal of this. By taking the reciprocal of this number, the power will become minus 2. So it implies, now bases are same, x is equal to minus 2. This is the solution for x. Now next it's 25th. What is 25th? It is 16 by 25 whole power x is equal to 4 by 5. Now you can see here it's 16 by 25. Can I write here it is 5 by 4? Can I write it 4 by 5 first square, then whole power x, because 4 4s are it's 16, 5 5s are 25, is equal to, here I will write 4 by 5 taking the reciprocal, power minus 1. I have taken here the reciprocal, that's why I have written here the minus 1, so that I can write it again 4 by 5 by 4 with positive power. So here you can see it's 4 by 5 whole power 2 into x, it's 2x equals to 4 by 5 whole power minus 1. Now you can see the bases are same, then I can write powers are equal to x equal to minus 1. It implies x is equal to minus 1 divided by 2, doing transposition of 2 to the right hand side. Next we will do the exercise 4 star. You can see the first one, it's very easy. Second one, it's easy. Third, it's easy. Fourth, it is easy. Now here I will start with the seventh one. What is seventh one? It's 1 mix 2 by 3 whole power minus 2. So this is the mixed fraction. First I will make it improper. 3 1s are 3 plus 2, that's 5 by 2 to the power minus 2. Then I will remove this negative power. So what I should do, I should take the reciprocal, that's 2 by 5 whole power 2. That's 2 2s are 4, 5 5s are 25. 2 by 5 whole square means 2 by 5 into 2 by 5. This is 2 times multiplied. That's 4 by 25. Now next it's 12th one. 11th one I will take here. It's 1 power minus 4 by 3. Now you can see here, I can directly write it's equal to 1, but I will show you here how it's equal to 1. I can write 1 power 3 into minus 4 by 3. 3 3 cancel. So I can write 1 power minus 4. That is 1 divided by 1 power 4. That's also equal to 1 divided by 1. That is equal to 1. This is the solution of the question. Now see the 12. So we can say 1 has any power, it's always equal to 1. Now next it's 16th one I will take. Yes. What is the 16th one? You can see 2. Then it is divide 32 to the power minus 1 by 5. Minus 1 by 5. I will write 2 divide here 32. You can see here by doing the prime factorization, 2 16s are, 2 8s are, 2 4s are, 2 2s are, and 2 1s are. So instead of 32, I can write 2 to the power 5. So 2 to the power 5 into minus 1 by 5. 5 cancel. You can see it's 2 divided by 2 to the power minus 1. Here we know it's power 1, so bases are same, in division powers are subtracted. It's 1 minus, then this minus 1. That is 2, 1 minus, it's 1 plus 1. That is 2 to the power 2. 2 into 2, that is 4. So its answer is 4. You should understand here what we used here. X power m divide x power n is equal to x power m minus n. Here m is what? 1, and n is what? Minus 1. Then this minus we are writing here. In place of x there is 2, in place of m there is 1, then this minus we are writing here, then in place of n we are writing this minus 1. Then we are solving this. This is the 4 here. Now you can see the page number 16, the same exercise. The 17th one, it's also very easy. 17th one, 5 by 7 whole power minus 2 by 3. Then there is a long bracket, and outside the long bracket its power is minus 3. Now you can see here it's 5 by 7 whole power, it's minus 2 by 3 into minus 3, because these powers should be multiplied. 3 ones are 3, 3 ones are 3, so it's 5 by 7 whole power, minus into minus is plus 2. That's 5 5s are, that's like this, 5 by 7 into 5 by 7, or we can 5 5 25, 7 7, it's 49. Now next you can see 18th one, it's also very easy. 7 to the power minus 2 into 7 to the power minus 3 divided by 7 to the power minus 5. You can see 7 to the power minus 2 minus minus 3. No, we should do here the plus. Here it's multiplication, divided by 7 power minus 5. You can see we will get 7 power minus 5, 7 power minus 5. We will get here 1. 1 by 1 is equal to 1. Now next it's the 19th one. What is 19th one? It is 4 by 25 whole to the power minus 1 by 2. Then next is into 8 by 27 whole to the power 1 by 3. Now you can see here I will write, instead of this, 2 by 5 square, because 2 2s are 4, 5 5s are 25. That's why I am writing square. Then into minus 1 by 2. Then into, I can write here 2 by 3 whole cube, because 2 2s are 4, 2s are 8 is there, and 3 3s are 9, 3s are 27 is there, whole to the power 1 by 3. Now 2 by 5 whole power 2 into minus 1 by 2 into 2 by 3 whole to the power 3 into 1 by 3. You can see 2 into minus 1 by 2, 3 into 1 by 3, 2 2 cancel, 3 3 cancel. You can see we are getting here 2 by 5 whole to the power minus 1 into 2 by 3, its power is only 1. Here we will take its reciprocal to make it positive. That's 5 by 2 into 2 by 3. 2 2 cancel, it's 5 by 3. It is the answer of the 19th one. Now look at the 21. Question number 21. It's 4 by 5 whole power x equals to 25 by 16. So I will write 4 by 5 whole power x equal to, it's 5 by 4 whole square. 5 by 4, because 5 5s are 25, 4 4s are 16. That's 4 by 5 whole power x equals to, here I would like to make here 4 by 5. 4 by 5 the reciprocal of it, so this power will become minus 2. It implies when bases are same, we are solving for x equal to minus 2. This is the 21st. Now coming to 22nd. What is that? It's 49 by 64 whole power x is equal to 8 by 7. Now you can see here, I can write here, it is 7 sevens are 49, 7 divided by 8 eights are 64 whole square whole to the power x, because 7 sevens are 49, 8 eights are 64 is equal to 8 by 7. So it will become 7 by 8 whole power 2 into x is 2x is equal to, here I would like to make it same, that is 7 by 8. I am writing here the reciprocal, so I should write here minus 1. It implies 2x equals to minus 1, x equals to minus 1 by 2. So it is the value of x. Now next I will do the 24th. It is 1 by 8 whole to the power 12 is equal to 16 to the power x. Now you can see here this 1 by 8, what I will do, I will write 8 power minus 12 equals to 16 to the power x. I will write here instead of 8 2 power 3 whole power minus 12. Instead of 16 I will write 2 power 4 whole power x. Now you can see here instead of 8 I wrote here 2 power 3, because 2 into 2 into 2 is 8. 2 2s are 4, 2s are 8. Then whole power minus 12. And instead of 16 I wrote 2 to the power 4. That's 2 into 2 into 2 into 2 is 16. Now I will solve it. 2 3 into 12, it is minus 36 equals 2 4x. Since bases are same, I can write minus 36 equal to 4x. Then I can write minus 36 divided by 4 equal to x. 4 1s are, 4 9s are. I can write x is equal to minus 9. So this is the answer of the question number 24.